Climate change and its effect on the coral reef community. Coral reefs, also known as the tropical rainforests of the oceans, are a vital resource for the coastal communities. They can be found along the shores of islands and continents in shallow tropical waters. Coral reefs play an important role in shaping the biomes that have dominated tropical oceans for over 200 million years. Over the past few decades, there has been massive coral reef degradation and mortality due to human behavior and natural variations in the reef environment. It has become a major concern as more research findings indicate the significant loss of species diversity in coral reef habitat. Declining in the coral reef community has occurred due to pollution sensitivity. Being able to survive off of nutrient-poor waters and within certain zones of tolerance to water temperature, salinity, UV radiation, opacity, and nutrient quantities are contributions that have been caused by climate change. Due to this apprehension, the question arises, what impact has climate change had on the coral reef community? Climate change affects coral reef bleaching in three ways: increasing water temperature, rising sea levels, and acidification. Increased water temperature. The warming of the ocean causes thermal stress on the coral, causing the loss of symbiotic zooxanthellae and/or reduction in photosynthetic pigment concentration residing within corals. If stress is too severe, affected corals die since the zooxanthellae population cannot recover by regaining the symbiotic algae in time. Fresh seaweeds are known to compete with corals for range on the reef, greatly benefiting from rising temperature and coral bleaching. The overgrowth of seaweed due to the degradation of the coral reefs can hinder the coral revival rather than allowing it to provide shelter and protection for animals that they may rely on corals for their habitat. Second, sea levels rise will cause an increase in sedimentation that can lead to the smothering of the corals. Sedimentation restricts photosynthesis, nourishing recruitment, and other crucial functional and biological processes required in order for the corals to develop. Changes in sea level will additionally cause coral development to decline due to drowning or lower light levels. Third, ocean acidification. The concentration of carbon dioxide in the atmosphere has increased due to the burning of fossil fuel and various human activities. As the levels of the atmospheric carbon dioxide increases, so does the level of carbon dioxide in the ocean. The addition of carbon dioxide decreases the ocean's pH concentration, further increasing the concentration of hydrogen ions, a process referred to as ocean acidification. As the ocean becomes more acidic, it enhances the difficulty for corals to absorb the calcium carbonate they need to maintain and protect their skeleton, causing the stony skeletons that support corals and reefs to dissolve. This detrimental progression of climate change has a protruding effect on the degradation of the coral reef community through the increase of water temperature, rising sea levels, and acidification. Although species diversity is currently existent, they will not be able to adapt to the rapid change of the climate, nor migrate fast enough to more suitable and sustainable areas. Unless substantial actions are taken quickly, climate change will ultimately cause the abundance of species to rapidly deteriorate and extinct.